Hi, I'm Mike Vincent, and I work for a company called ODH, a startup. I work in the cybersecurity with sales.
Hi, I'm Sal. I'm an embedded software consultant.
Okay. Is that the end of the line? Anybody have a card they didn't want, or take it? There's no rush. We're not doing the drawing now, but okay. Oh, there should be a pile of them going around somewhere.
They're still going.
Yeah, there should be plenty of cards.
I brought 100. We shouldn't be at.
Yeah.
I want candy. One entry per person.
Remind people what the
cards
are for.
We're going to do a drawing later, so you just have to have them done by later. That's all.
So I should specify one person. Okay, did you get it to work?
Yeah.
Oh, okay. You want to?
Here, I'll say something. Are you done speaking?
I think I'm done.
First of all, a big thanks to Jeff, who basically put together this entire platform. Did an amazing job. Scored us a room at Microsoft Nerd on top of it all, which is great. And hopefully we'll be meeting here on a regular basis. I think that should be okay, generally.
Yeah.
And it's, I think, a good location for everybody and obviously a great space. So thank you everybody for coming out. My name is Paul Roberts. I'm the co-manager of the Security of Things meetup with Jeff. And I am the editor-in-chief of a publication called The Security Ledger, where I write about security and IoT. I'm also the organizer of an event. It's coming up on June 19th called the Security of Things Forum, security-of-things.com. It's happening kind of co-located with PTC LiveWorks, and it's a whole day of security and IoT content. So if you're interested, I've got cards over here with like a discount code and registration code on it. I'd be happy to talk to you about it. And there are only like 25 of those. So if you want them, what I'll do is I'm going to leave them up here in the front and come get them. In terms of the meetup, thanks very much again for coming out. It's great to see new members. We are live streaming it, and I did send out a link. There will be a video of this on our YouTube channel after the event. We are always looking, we're talking to some companies about doing some sponsorship of the group so that we can maybe upgrade our food and beverages, maybe do some different locations, and also upgrade our online streaming, because I do want to make this available. We have more than 2,000 members in this group, but obviously we're not getting 2,000 people to come out every month. A lot of people are either not located in Boston or further out, so we want to make it more of something you can attend online as well as in person. So kind of stay tuned on that. The other thing I would say is we're always looking for speakers, and we're always looking for suggestions on topics. You guys, many of you are subject matter experts in this space. If there's something that you are curious about but not hearing about, or read about and want help kind of crowdsourcing that or digging deeper or finding a local expert who can speak to it, bring it to Jeff or I. Either message us on the meetup, via the meetup interface, or just shoot an email to us personally. I'm Paul at Security of Things. Jeff is
g.kohler@computer.org.
g.kohler@computer.org. We'd be happy to figure out a way to get that talk or idea featured here. And I think that's about all I had for you. So yeah, Security of Things coming up next month. Let me know if you're interested. I've got cards up here with a discount code, and I'd love to see you all there. It's going to be an amazing day. We've got a really good panel with, we got a panel on securing real world connected device infrastructure, connected device deployments with Chris Resendez. We have the CTO of Six River Systems, the warehouse robotics firm in Waltham. It's going to be on that panel. Rob Black, who's come in from Fractional CISO, who's spoken to us before. Former security guy at PTC, is going to lead a panel on IoT standards with Underwriters Lab, with somebody from Johnson Controls. We've got a talk on cyber physical security with Josh Corman. We've got the folks from Senrio, security research firm, doing a presentation on lateral attacks via connected IoT devices, and how those work, like very down the weeds. So there's going to be kind of something there for everyone, and you also get access to BTC Live. It's kind of, honestly, between you and me, kind of a backdoor way into BTC LiveWorks for less money. So let me know. And without further ado, let me hand off to who's speaking first. On to speak. Come up, dear friend.
All right, thanks.
You're all set up here with.
Yeah.
Do you have a mic?
I'm gonna use that one.
You can use this one.
Yeah.
All right.
Works.
Works. Thank you.
Okay.
Thanks, everybody.
All right, thanks for having me. My name is Scharler. I'm with Mathworks in Natick, Massachusetts. So it took me like an hour and a half to get over here. It's like a different world over there. But I lead up the R&D efforts for Internet of Things for Mathworks, and so the one thing I'll just get out of the way is I'm the toaster guy. So I connected my toaster to Twitter over 10 years ago, and it's got thousands of followers. That
You're that guy?
So this got into Time Magazine and all kinds of crazy things. But I had this idea. I saw Twitter in 2007, and I was like, I have a killer app for it. Things need to be on Twitter to make it have a legitimate purpose. And no one was, I had this pitch deck and I went around trying to get investment money for that idea. And no one thought that was a great idea.
But your toaster did.
So I used my toaster as an example to pull that off. That led me to create a IoT platform 10 years ago called ThingSpeak. And now ThingSpeak is a part of the Mathworks IoT solution. So, which I'll mention a little bit at the end. Jeff heard that I was over at IoT World last week, and I got back last night. I stayed for the Maker Faire over the weekend as well. And so he just wanted to talk a little bit about what was going on. There's lots of IoT happening, and IoT World's a good show if you just want to see a cross section of all the things that are going on. There were probably three main topics of the event. I heard someone mention blockchain already. So that's one for the bingo card already tonight. Is anyone in AI? That's the second one. So it's blockchain, AI, and IoT was the big theme of the week. One of the themes also is pushing the machine learning to the edge was a theme as well. I'm gonna talk a little bit more about that as my talk goes on. That was one of the themes. The Maker Faire was really awesome. Imagine 100,000 students and makers building all these crazy things and showing up at fairgrounds in San Mateo, California. You have students, you have Adam Savage, and you have a giant robotic giraffe breathing fire and things like that. So it was a really cool show, but lots of IoT was at the event. At the DigiKey booth, if you're familiar with DigiKey Electronics, they had a ThingSpeak demo with a little atrium. Particle IO had a presence at Maker Faire. Bolt IO had a presence there. A new company called Moddable. So lots of IoT, and even Sony has an IoT platform. And they all launched at Maker Faire, which was really an interesting thing to see. So my talk today, just going to talk a little bit about some security concerns. And so from my R&D perspective, I'm only going to try to just leave you with kind of a new way of thinking about IoT security. I'm really not going to have many solutions for you, but just maybe plant some seed thoughts. Maybe it will start a good discussion when we open it up for some questions or afterwards, or maybe 2 weeks later, you're like, maybe I can do something about one of these things. So just going to talk about a few of these things. So with all presentations, I kind of start with Google. I just searched IoT security. And what was interesting is Helium came up as one of the paid advertisements there. So that complete IoT toolkit, I think, could be had by one or two people here. unless you put multiple cards into your same name, so that'd be cheating. But, and then I get bored of that, so I always type in IoT security meme. I put meme on all my searches just to see if people have created memes. And this is the results of that kind of search. Some of the thoughts that I have about IoT security is that everything is out of date. And that's the problem. That this is one of my keep aways. So this is one of the seed thoughts I wanted you to have in your head. And so where I thought about this was, this is a screenshot from Android and iOS, and you can see that, you know, I have this Opera Max and it says update, and then on iOS it says update all. And so I thought about it like my phone is out of date all the time, and I have that 24/7 near me, and I'm looking at it for most of the day, and it's out of date. And it has all these options. You know, there's other options like when do you update? You know, is it only when you're connected to Wi-Fi? And so some of these, the reason I bring this up is just think about all of the IoT devices that may come into existence over the next few years. If I asked you what firmware your refrigerator is running with, what is it? Is it up to date? Is it the latest? Does it have security vulnerabilities? This is one of my keep aways, is when do you update the system? When do you, should you do this on behalf of the user? Should it be silently? Is it opt-in? What if it's a disruptive upgrade? What happens to rollbacks and things like that? So it's a seed thought. I don't have a great solution for this, but in some of my R&D work we were talking about before, is some of the IoT systems we do is inside the network premise. So it's inside the four walls and it doesn't leave those walls. It's more like the Internet of Things, or the Internet protocol for things, but not necessarily IoT. But even there, everything that we connect to a network is out of date. The routers we connect, everything we try to manage, everything has a vulnerability, or and it's just out of date. So another thing that I was thinking about is we're just going to be surrounded by things. They're everywhere. They're out of date, and they're going to be everywhere. And that kind of scares me. And then the next thing is, how do you find these things? Have you tried Shodan.io? So yeah, search addresses and things like that, and you'll be surprised what you'll find on this. But the things are everywhere. And so we have all these things near us and near and dear to our hearts. And they did a survey, and you can see this was a nice bar chart of the survey, where they asked about, are you aware of any of the vulnerabilities of these categories of devices? And you can see, if you ask consumers or just general users, what has vulnerabilities? So they think about it. You can see the top 3 bars are laptops, mobile phones, and tablets. People are generally aware that there's vulnerabilities of those things. But the year the survey was done, there was vulnerabilities in some software and some IoT connected devices, things like that. And you can see there's just going to be things are everywhere. Plus, vulnerabilities are not on top of mind. So these things are starting to alarm me. So what is this new way of thinking? So this is the seed thought from my R&D for the last few years, is trying to think about the problem a little bit differently. And so one of the things I realized with all the voice control type systems, I can basically ask my voice controlled systems to do something, and it does it. That's a command and response type scenario. And so that's also very scary. I can tell it to do things that it probably shouldn't do. It's not sentient in the way that how is, where it's going to do what I'm going to ask it to do for most intensive purposes. So what I've been working on is an idea called modeling behavior. So where my input into an IoT system is just one part of the system. So if I ask the temperature to go to 100, I'm trying to think about that differently. How else could we achieve the same goal? Are you trying to get it to be warmer? And so that's a different goal than 100. And so it just becomes an input system. And like I said, it's just kind of a seed thought for you to think about this. One of the things that's happening that's allowing some of this to be possible is if we do machine learning on the edge. And that was a theme of IoT World last week, where we're pushing more and more of the intelligence out to the edge. So could these systems realize that this is not a fair command to do? And the problem's even worse if you go past voice control and you say, if you give an API access into one of these industrial IoT systems, what do I trust every command that comes through? And the other thing we do is trust every piece of sensor data that comes through the system as well. So how do we know it started at an edge device, at a sensor, and it is something you should model your device? So think about just in our daily lives, if someone says it's going to rain like today, you grab an umbrella, and just that piece of information changed your behavior. So imagine more and more critical things trusting these underlying values. I could make everyone just carry umbrellas by changing sensor data. And so you're carrying around on a sunny day your umbrella. That's a silly example, but just imagine how disruptive if you don't trust or don't know where the data is coming from. So this is how I'm thinking about the problem and some of the concerns. So can we model behavior? Can we test it on the edge devices? And that's where I'm at thinking lately with my research and development. Some of my customers, they have concerns. They have different concerns. So I mentioned some security concerns that I have. So I have customers that are worried about these two different things. So they're worried about IP leakage, and they're also worried about trusting the digital twin. And so digital twin is another phrase you should be familiar with when you get into industrial IoT. So I think of it as if you have a thermostatic control, and on that thermostat you're set to 70, there might be a virtual representation of that somewhere else that shows a dial at 70. And so now you're trusting the two. It's a twin because if I change one in the virtual space or update the local one, they should stay in sync with each other. And so we're starting to do things where we trust the digital version of the original asset. So if you're a machine controller, you're trusting your HMI panel versus trusting the actual system in front of you. It's like turning right when you know there's not a road, but your GPS tells you to turn right. So that's one of those things. But I'm an optimist. That was a lot of negativity. So I'm going to try to cut the tea off this and keep going with the idea. The last part of this that I wanted to talk about is some of our solutions and some of the ways you can go from here. So I mentioned ThingSpeak. So ThingSpeak is brought to you by MathWorks, and it has analytics built in. So you can do some of the things I was talking about. You can do correlation of different data sets. You can do machine learning algorithms, do those things on your data sets. The platform has 300,000 developers around the world, and it's starting to, there's a lot of activity. So if you're not familiar with ThingSpeak, you can just go to Google and type ThingSpeak and then another word, you'll see integrations with all kinds of different platforms around the world. So some of my favorite IoT examples that use systems like ThingSpeak and other IoT, and they get huge return on investment. And so here's one where it's just a solar panel and a sensor that says when the trash is full or not. And so it's a very small amount of information. It's literally a 1 or a 0. It's either full or it's not, right? It's either you're toasting or not. You can see how this all connects. But in this case, a city can do all of its route planning differently, and they get huge amounts of return on investments with just a small amount of information. But again, so this is where I was talking about the source of the data. So if you trust that this is full and you drive a truck to that, you're changing behavior because there are systems in place to tell you when to pick up trash. If you go further down Route 9, we have a camera that's facing Route 9, and we're showing that using ThingSpeak, identifying cars and their direction. And so what it does is send up a count to ThingSpeak, just a raw count. And so you can build this, you can build a histogram using MATLAB analytics that's built into ThingSpeak to figure out the best time to get into work. I keep trying to tell my boss it's after 10, but and before 2. So it just works better for me. So that's our traffic camera, and this is running on a Raspberry Pi, running a vision system and modeling on the Raspberry Pi. And so this is like getting the intelligence on the edge versus streaming the video to the cloud and identifying the cars and then sending some kind of inference back. You might have had this question burning in your mind: Do hamsters run a marathon every day? So they do. You can do this with IoT. So this is one of the projects, many projects on ThingSpeak. There's one of it had its own Twitter account @RunnerHam if you want to follow this hamster. So they count the revolutions, turn the revolutions into distance, and you can prove out these kind of theories. Another thing that you'll see a theme in all these kind of examples where you can take small amounts of information and maybe do something with it. If you have a burning question or you have some kind of thing you need answered. This is using weather station data. We have about 30,000 weather stations on ThingSpeak, and so we're able to build very detailed weather models and radiation and air quality type sensors. So one of the things you can do with the analytics is start to predict when to harvest certain things. So you can take just basic weather station data and turn that into predictions by using analytics in the cloud. To kind of like tell you where our focus is right now, because everybody's trying to figure out where to enter the IoT space. You're trying to think. I just wanted to kind of boil down where I'm seeing the most traction from my customers and the people that are using our services. Predictive maintenance is #1 by far. So it's been our focus for the last few years, for sure. Smart agriculture is another one. That seems to be an easy return on investment. If you overwater plants, you tend to over-fertilize as well. And with a little bit of mathematical modeling and some sensors, you can optimize all of those processes. And then in general, if you're trying to find a mental model for how to figure out where to think about IoT and where it could exist. Anything that can improve an existing system. So you take, that pet feeder was an awesome product, add some IoT, now it's an internet connected. That's something that a lot of people do. If it can provide situational awareness. So situational awareness is where you get insight into something you didn't have insight into before. This is like putting a temperature sensor in a room, and now you know it's 73 degrees. So that's what situational awareness is all about. The other one that just has immediate ROI is anything that can reduce a truck roll. So a truck roll is someone who delivers propane or oil or any kind of consumable like that, or picking up trash at the right time. If you drive to a trash bin that's empty, you've wasted a lot of energy and time, probably backed up traffic, did those kind of things. So anything that reduces that, and so this is where I get a lot of attention right away. So to talk about predictive maintenance, to leave you with something, this is definitely our top area. It's a complex problem, but you'd be surprised that you don't need a lot of sensors to figure out when things and systems are going to fail. So one of the things that you can do with machine learning and predictive maintenance type toolboxes is that you can take vibration data and you can turn the vibration data from the time series to the frequency domain, and you can do analysis, and you'll find out that most machines run in some kind of maybe a bimodal distribution or some kind of distribution of vibration data, which you can clearly see in a frequency domain, but not as obvious in a time domain. And you can get a baseline for a machine. And what will happen is those bimodal that bimodal distribution will shift over time. And you can get, if you measure that periodically, you can get a velocity, you can get a time, of useful life that is left. And so that's a very interesting thing. It's not a difficult problem in terms of understanding the mathematics. It's sometimes getting reliable high frequency vibration data, downsampling it, doing the conversion. That's usually the typical problem. So we focused quite a bit in that space. We have an ebook that will help, that helps tear this part down for anyone if you're interested in trying to figure out this next area. We believe it's a big one. So we have an ebook for it, and we have a toolbox, and predictive maintenance algorithms are built into the ThingSpeak platform. So to leave you with some takeaways, if you want to try thingspeak.com, you can do that. There's our documentation. That's the link to the ebook. So if you go to mathworks.com/discover/predictive-maintenance.html, you'll get to it. We also support lots of hardware. So we have a hardware catalog. So if you have different types of sensors or they're connected to different IoT platforms, you can get instant access to these platforms. And if you want to follow me, you can follow me on Twitter at Scharler, or follow my toaster at my toaster, which more people are way more interested in that than me. But all right, thanks for having me. I think Jeff is going to get a mic for questions if you have any. Want to try this one?
No. I think people can ask first one.
Yeah, we can probably. Okay, go ahead.
Take it old school.
Start here.
Yeah, so I know that MATLAB can use MATLAB actually to modeling stuff, right? Do you have any sort of target accessibility as well? Like, let's say I want to model some logic in the MATLAB, and then I generate the code for actual target and then run the same logic.
Yeah, you can. So that's one of our benefits. So once you get the mathematical model, you can actually target hardware. You don't have to do the rewrite. So the modeling is done in a product called Simulink. You can stay in Simulink as a visual system. It's quite powerful for these systems. So you can output the C code, or it can be native to that target. That's what we call it. We call it target. And for experimenting and things like that, if you have an Arduino or a Raspberry Pi, we can target those. You can put very complex algorithms onto an Arduino or a Raspberry Pi, or you can go all the way to a SpeedGoat real-time system that would be used on an airplane or a car or something like that. So we go the whole spectrum.
Can you even distribute the functions from across the cloud and then edge and then actual device? These days, things are sort of distributed. Like if you look at the Microsoft, they have a Azure IoT platform, or they have all those some very complicated stuff you can do in the cloud.
Yep.
A little bit kind of aggregated data into the edge.
Yep.
The device is sort of collecting data. Can you actually do that?
Yeah, you can do all three pieces. So if you're cloud native, like on Amazon or on Azure, you can do all that. It's like on a Lambda function or a function on Azure. Anybody else? Go ahead.
I have two questions. One is can you comment on the quality of your basic precision and the core quality predictive maintenance algorithms? First question. Second question. So is this predictive maintenance algorithm is it very generic, or is you have to do lots of customization to different areas?
So the quality, you can take a look at the documentation as far as that. But how our tools work is we build a visual way to explore the algorithms. So you can try out different fits, you can train different ways to see what the results are, or you can have them all compete against each other and try to come up with a lower cost algorithm. So we try to make it so you can do the exploration part. Once you get past exploration, then, you know, getting into the implementation is probably, you know, real adjustments and, you know, trying to optimize for that particular problem. But you can start with a generic data set that you've captured, or start with one that we include, and then you can start doing the training and trying to figure out what the RUL or something like that is. All right, over here.
Can you talk a little bit more about machine learning on the edge? Particularly curious about like how much of it is like real time and something that drives actionable insights on the edge?
Yeah, so the question's about machine learning on the edge, right? So one of the things is like object detection or presence detection, things like that. So you can start by taking that video and you can get a trained neural network, or you can use a pre-trained neural network and just swap out the last layers of the neural network and optimize those for yours. So our product allows you to output that as a model, which can be deployed on hardware. So it runs without the internet connection when it's deployed on the hardware. And so if you make changes or you learn something new, like if it's taking data from like a fitness band or something like that, and now you're doing a new activity, and we figure out what that activity classifies as, then you can redeploy the algorithm to the edge, and then now you have that piece of information. So it kind of goes through a process where you stream a lot and you learn or classify, and then you put down the model to the device and it runs autonomously, and then you learn something new, and you kind of go back and forth. And so the data, we call it a data reduction phase. So in the beginning, you have lots of data that you have to get out of the system, and then it gets less and less and less. And so on a fitness band, instead of streaming all activity, you can just stream the classified activity with some kind of confidence score with timestamps. That's a lot less data than the alternative, which is every step you take or every accelerometer measurement or something like that. Make sense? All right, go ahead.
At the beginning of your presentation, you were discussing the notion of a problem space, basically that things are sort of out of date.
Yeah.
And so I was wondering if you could expound on that, because it sounded like you were sort of saying, I was wondering, were you sort of implying that there must exist this ideal state, that everything is up to date, but then what would that mean? And so, or were you sort of suggesting, you know, it's like, to me, the way I was reading into it was that, well, things are out of date, meaning, well, we have bugs and we have security holes. So does there exist an ideal state where we don't have any of these things? Or were you trying to, you know, you were uncomfortable with the space, and it's sort of like, well, what are you uncomfortable about? That seems to be the normal state. So should we interpret that differently, that things are always out of date, so why would I care?
Yeah, I think you answered it throughout that journey. So, but in seriousness, it's a fair question. I wanted to plant that seed for this kind of discussion. The reason it's partly the awareness that we may buy a product or pick a car or we're going to make consumer choices based on connectivity. We're also going to make choices based on, does this work with Alexa, right? If it doesn't say works with Alexa on the box, I may not even purchase that particular IoT device. So what I'm getting at is you're going to make decisions. And so you might buy a connected product, but not think of it as something that's got software or vulnerabilities or things like that. So tying it into that survey where people see compute devices as being vulnerable, but not these edge devices. They're also running their software. So part of it is an awareness. If your phone is out of date, how likely is all your IoT devices to be out of date?
And also, like,
systems?
we already see different models of ecosystems, some of which do a better job of maintaining security and keeping the endpoints, up to date. For example, kind of iOS versus Android, right? So while you're right, there are always going, if you hundreds of millions of endpoints, there are always going to be some that are out of date. Like there are kind of degrees of competence in maintaining like a herd immunity from keeping too many devices from being out.
Yeah.
And I think that's kind of where we need to be going.
Yeah, I like the analogy to mutination, things like that. So the herd having a certain percentage to be not vulnerable versus vulnerable brings down the rest of the herd.
Right.
All right.
Beginning of the presentation, you spoke of and just questions the security of all these devices, which is, I think, slow down. Do we really want to do it? How are we going to maintain them? But on the other hand, you're saying we should put more you can put more sensors out there to get more data, and simply pushing out the devices quicker. How do you balance off the two? How do you balance out the two?
So that's the question. So I tried to leave you with some points of modeling behavior was one of the areas. So so some of the thought experiments that I've done to try to get to some solutions are just using an ATM machine. Like this is one of these things that we do. This is all that we do on a daily basis. Things like that. I take money and I buy something, or I use my credit to buy something. But we never take into account all of the data that is available to the credit card system or the banking system. All we try to do is model, are they in this city generally, or we try to come up with those types of things. But they know where we potentially could know where phones are, you can know where your locations are. I'm not saying this is a great use of IoT, but what I'm getting at, it was a thought experiment that got me to some conclusions, is that we're not taking advantage of context type data. If you say to turn your thermostat to 100 degrees, one of the benefits you have with that is that these voice controlled systems know that I'm there. That's context awareness, where they heard my voice, they heard it happen. It wasn't an API call that came from remote that somehow authenticated into a system. But if I can hack a baby monitor and get my voice on the baby monitor and do that, then that context aware system starts to break down. So the idea is it's just taking advantage of all of the things that we have data on. And so that's part of what I'm trying to get at. I think that's how it can help. Yeah, it's you.
I haven't put a lot of thought into my question, so it's going to be a surprise to me.
We'll all be surprised.
Yeah.
It's a journey.
But let's forget about harvesting, but think about your example of somebody in the harvest, different locations. What about people as things and what they reveal about an area or climate or sociology?
Yeah, that was pretty well thought out, so congratulations. So another thing that came up, so early days of Twitter that got me thinking a lot about this, just to tie it back into something. There was a earthquake that happened in Maryland, of all places, right? And so Twitter was pretty new. And when Twitter started, you just did status messages. I don't know if you remember that. It was like, I'm at the store, and I'm eating this. It was kind of a very basic, now we change, the world's minds and things like that. But, so started off very differently, but they used to encode the location in all of those tweets. And so this earthquake happened. People woke up and said, hey, did you feel that? And so geoscientists were able to figure out the epicenter of the earthquake by analyzing the tweets. And they got into a reasonable radius of where the actual epicenter was on their seismometers and versus the tweets. And that got me thinking, that's a social experiment on scale. So I think that,
Thank you.
I think there's some things to be said about that people could be sensors.
Not so much a question as something that keeps me up. Because we're working on biometrics for the credit cards.
Yeah.
And can't update. Once it's in the field, it's out there forever. And I guess you have to really kind of think about credit card as you know when things get open and you have issues that you have to start looking at the credit card as opposed to
Yeah.
because at best you got, it's gonna be out there 3 to 5 years and you don't want it necessarily. Do new ones all the time, you can't update them. I
Yeah.
wonder how many other devices we're gonna put out there that are not truly updatable at all.
Yeah. That's interesting. So we're paying by phone more commonly. I start to see it online more. But one of the things that you have an accelerometer on that phone. With good accuracy, they can determine the height of the person that has the phone just by analyzing the accelerometer data. And so it would be different, if you go to purchase something and you're a different height. I mean, those are all like little things that could be done. That's using different data for the problem. But that's kind of the message of the seed thought that I wanted to put in there. Some of it could be on the creepy side, or it could be for useful side.
And that's actually in the biometrics, I can't talk too much about it, but we're trying to look at different mechanisms. If it's a live person, how do you know it really is you versus using a piece of tape?
Yep. All right, more?
So now I'm a developer, so I'm thinking in those. So MathWorks and the tools, everything, they have been really, really good in visualizing electronics and then converting them into program. How much thought have you guys given into, at that moment, at the design concept level, telling the developer, hey, these are the things from a security point of view you should be worried about, like creating a data model, a threat model, right then and there, and pointing them, okay, these are the things you need to be worried about. And then once you are doing the algorithms and whatnot, doing static code analysis and all that type of stuff.
Yeah.
Making sure that at the development point itself.
It's part of the requirements. It's part of the system architecture. So I like that. So we're kind of like AI first, mobile first, and we'll be security first. We'll do all three first. I think that's kind of but I think it's a good idea to add security to the design requirement phase. I think that's a really good thought. They're gonna help out. All right, you coming back for more?
Yeah, I guess I need more views. So the other topic that we've sort of been dancing around, which was the trusting the data.
Yeah.
So, or questioning the commands, don't say maybe take them literally or do that. So we've been discussing sort of from a machine point of view, whether the machine should actually trust the data and whether it should have other avenues of developing trust. You also brought up the model of whereas how do we trust the digital twin? How do we build up that trust so that we can then buy into that system that the digital twin is just as good as that?
Yeah.
And right now, it seems like we do it in a really dumb way. Someone says, this is good. We go, okay.
Yeah.
And we just run with it.
Yeah.
But
green is good. I hear that on an HMI panel, right?
Yeah.
The light's green, so
I mean,
we're okay.
should we actually dive in, we dive in deeper and say, well, we're like animals, so just program the system to be like that? Or do you think we actually need to develop better mechanisms for determining trust because of the fact that I can be spoofed?
Yeah, like a Turing test for trust.
Yeah.
You gotta pass the Turing test in order for it to be artificially intelligent. And then that's a good thought experiment. I'm gonna noodle on that one. I don't have a perfect answer for that. I wish I did, but
Well,
I'm
plus
gonna really think
we've
about
already
that.
seen, like with the Stuxnet attack, right, and others that, we know malicious actors are capable of manipulating HMIs to misreport the operation of an instrument or a piece of machinery, so that it can in effect destroy itself while it's telling you that everything's hunky-dory. So, you're right. I mean, there is a question about how are we measuring things? Do we trust what our HMI or the GUI on whatever we're monitoring this piece of physical machinery is reporting to us? And it's going to be increasingly the case, I think, that malware is going to seek to create a division between what is happening on the device and what the device is telling its operators is happening. So how do you measure that in a way that is mechanical and verifiable?
Yeah.
Outside of software.
Yeah, it's a really good thought.
I think we'll have to get two-factor authentication on that too. One sensor, but more than one sensor, two factors,
Yeah.
multiple factors to get to that.
And there's clearly an opportunity for blockchain for trusting the sensor values, right?
Mm-hmm.
That's one of the things that could be maybe if I can go back to 2007, say I got a useful idea for Twitter, now I got a useful idea for blockchain.
If you go back to 2007, you would be buying all the.
Yeah, all the Bitcoins. So, all right.
So, one more thing, different topic. You were talking about the smart, dumb devices, smart like trash barrel.
Yeah.
And then you go as the IoT devices. So it's starting to sound like smart cities or safe cities.
Yeah.
For example, you actually targeting that space, the smart city spaces.
Yep.
You know that edge velocity is doing things. You're looking at all these sensors for these emergency. Are something on armored things where they're tracking people, say in the stadium, but also not only for place but their velocity. So they can determine that they're moving quicker than usual. There's some event, something's going on, something's coming ahead, something's moving.
Yeah, activity modeling is kind of the fresh frontier for machine learning and deep neural networks. Is trying to figure out activity, and they're doing things like classifying things like pickpocketing from video, and loitering is an easier one, but they're trying to classify activity through video, and they're doing it at like train stations in China. They have experimental systems. That is a frontier for sure. How are we doing on time over there? We're doing good?
Yeah, good.
Okay,
But
just want to make sure. I think we're gonna get to everybody here.
Yeah, maybe one more question.
Anybody else have a question? All right, go ahead.
So, how are you dealing with the privacy of your data?
Most of the time, we deal with closed wall R&D, so that's an easier. We start more in the R&D prototype phase, and our tools go out into production, but we kind of start with a lot of privacy concerns in the beginning. So that's a whole nother issue to deal with, is to consider if I use other data sets to figure out behavior, can you even do that? Like, is it even possible with privacy laws and things like that? And then what do you do with the data after that? So we stick to the data collection is for that project and not outside of that. That's how we handle it. I don't know how other companies are going to deal with that problem. All right, one more.
Actually, I just wanted to continue on what you were saying.
Blockchain.
Blockchain, yeah. No, the behavioral prediction. So I like the whole idea where it's sort of like, oh, the crowd's all going this way, but one person's going that way, so therefore. But I want to say it's almost like trying to predict the weather. Can we actually determine a truth out of the behavioral patterns? Because what is the cost of being wrong? So like on weather forecast, when they say, oh, we're going to get hit by this massive hurricane, has an economic cost.
Yeah.
And when the hurricane does not happen, or it does not hit your part of the country, then it's sort of like, God, that was expensive. And in some places where it's wrong too often, you lose credibility and the system dies.
Yeah, that goes back to your trust question. Do you grab your umbrella because the weather person said that it's going to rain? But I also like to think of this. We're from Boston, or at least from the area. We had kind of a ridiculous March this year, right? Is that a good way of saying it? This year, yeah. It was a ridiculous March. So like 3 nor'easters, and we have a new word, bomb cyclone, and all these things to scare us and buy more toilet paper and things like that. but they were right every time this year, which was a very, they've caused the opposite problem for me. Because I used to have hope that they were wrong and I could go about my day and not worry about it. Now, I know that they're probably right. So that's another issue. I think there's the right data is there. So I can give you a small example of this is, NOAA has been collecting all kinds of radar data, and that data is all open data, which is freely available to all of us. And they've been collecting radar data for 30 years. They do some processing and they separate the signal from the noise. They give the forecasters the signal. So, but pumping all of the data into new machine learning algorithms, they're finding out that there's data in the noise that we've ignored for 30 years. So, for one of the things they've gotten from the noise is bird migration paths. Birds fly in front of a radar. That's noise to the weather people, but it's information to biologists. So I think we're in an interesting time where those things are more possible than they've ever been. So, and we just have so much data and so many data sets that correlate. So I wish they were wrong more often on weather. That's my point. All right, I think that's enough of my.
Thank you, Hans. That was a great talk. I think everyone was interested. Yeah. So next we've got Mark coming up from Helium. While he's setting up, I'll just see if there's anyone who has any group questions not related to the talk or anything like that while Mark's getting his thing set up.
And I'm gonna pass around just a sign-up sheet and try and get a sense of who's coming week in or month in, month out. Name, email, but we're in GDPR now, so email's optional.
I don't think GDPR is here, is it?
Well, 3 more days.
But in Europe, in 3 more days.
Well,
It's Friday.
it affects all of us.
Okay.
Of course.
Yep.
Any EU citizens in the room?
You can request to be removed.
Stuart, for now. For now. Depends on how things go.
I'll say.
They can make a lot of money if they provide an option for everybody who wants to be in GDPR. Come on this site and register with us, and now you're
Exactly. They can move here.
I'm sure everybody's getting, is everyone getting the emails in their inbox now? Like everybody,
Yeah.
But the thing is, the
Tell us
use
you
is
want
not needed.
Terms and conditions have changed.
Yes. This is like the greatest unsubscribe ever.
These 2 article ones. Try one of these. Just try one.
One that's working, label A1.
Where's soda and stuff outside? Gotta go.
I don't know that is the key.
Okay. All right. So without further ado, Mark Phillips from Helium. He's going to tell us about the cool stuff Helium is doing in the IoT space with the open source.
How's that? Success?
Success.
People in the back hearing me? Great. All right. That doesn't work.
It's working.
Working? Good? People can hear me?
Yep.
All right. So one more reminder that we're going to give away 2 of these. And I'll talk about what this is, but this is a hardware development kit to get you building some stuff. Actually, they could send data to Hans's platform quite quickly. So this is the Helium development kit. We're going to wrap up these at the end of my talk.
Does anyone not have a card that wants one?
So get in there at some point.
Are these the ones that have already been given?
Yeah.
Oh, you want to fill one out?
Okay, so I'm here to talk about Helium and what we're building and this crazy, very ambitious, and very exciting thing that we're calling the world's first decentralized machine network. You need to burn the acronym DMN into your brain. DMN. Centralized machine. My name is Mark Phillips.
Name or name and email?
Name and email, name doesn't matter. So I'm Mark Phillips. I run business development and sales engineering for Helium. I'm based here in the Boston area. I actually live in Hingham, just south of the city. By way of introduction, before Helium, I was part of a company called Basho Technologies, which, has anyone heard of Basho? I see one person shaking. Okay. So Basho was a company founded in Cambridge that built a quite useful and novel distributed key value store for any kind of database and distributed systems out there. And so they were based in Cambridge. I worked there for a while, and came over to Helium in about 2013. Which is when we were founded. So a bit on our background and generally about the talk. So I'm going to talk about our background. I'm going to talk about kind of this big proposition that we're putting out there in the IoT space, which is meant to kind of get people's attention, cause you either to agree or kind of violently disagree. Hopefully one of those two reactions will happen. And then I'm going to talk about kind of the DMN here, this distributed machine network that we're building and the mechanisms that we are kind of putting in place to make this possible. And hopefully tie it all together with a use case that touches on the security kind of trust pieces of the network and kind of go from there. So feel free to ask questions during the talk. I'll obviously take them after the talk, but off we go. So we were founded in 2013. Has anybody heard of us before this? I know Hans had seen us at a conference. One hand. We've been around for a while. Founded in 2013, towards the middle of it by a guy named Amir Haleem and then Shawn Fanning of Napster fame, oddly enough. And so funded by, big shots in the VC space, Google Ventures, now known as GB, Coastal Ventures, First Mark Capital, and a bunch of fantastic kind of angels and other investors. And so the goal for us was to, at the time, build actually what looks quite close to what we're about to kind of release, which is a public network meant for wireless and sensor data. So has anyone here spent enough time building an IoT product from the ground up? In any all, love it, hate it. Few people. So our mission was to give developers, companies building connected products, primarily in the enterprise space initially, a wireless link that was secure and easy to use that got data from the edge. It could be in the middle of a city, it could be on a farm, it could be in a factory, back to a cloud-based application. And so we've raised to date about $35.5 million across seed, A, and B round from all these companies. But it is our belief that fast forward 4.5 years now, that IoT has largely failed, right? So we're at this point now where the hype has kind of come and gone and people are trying to find actually useful things in the space. And enterprises have had tons of POCs that have started and stopped and some of them have been successful, and we've got plenty of people that have built successful things on Helium. But in our opinion, the space has not lived up to the hype, and I say that because we feel like Helium is to blame, much like a lot of our competition is in the space. So, a little bit on that before I get into what we're actually doing. So, what is wrong generally with IoT? There's a confusing morass of protocols and transports. You've got your low power wide area network stuff, you've got your cellular stuff, you've got everything that's kind of 15.4 based, your Zigbees, your Z-Waves, your threads. There's MQTT, HTTP. It's hard to make sense of all this stuff. And as a company building a product, it's daunting to approach. Somewhere related to that, you've got vendor lock-in and hidden proprietary parts. Again, Helium very much guilty of this. Helium specifically has a module. On that module, there's a dual band 15.4 radio, which runs a proprietary wireless protocol, which is fantastic, but certainly falls into the vendor lock-in and proprietary piece. You're building on pieces that are ultimately very useful, but when it comes down to it, they're trying to lock you into the business model. And as a company trying to build something for 5-10 years out, we don't think that's the right way to do it. You don't have any shared infrastructure. So if anybody follows people trying to build out these low power wide area network things in the United States, and at least one person from Verizon myself, someone mentioned Verizon earlier, it's tough to take advantage of kind of competing companies building against the same protocol and same specifications, because they're all self-interested and nobody wants to share resources. And as a company building on those, it's very, very hard. And then it's tough to own your own data. There is at least one wireless provider out there running in the United States that mandates that the data that you send, low power wide area provider that mandates that the data you send to their cloud is theirs. You have to store it there for a year, and they have access to it. That's ridiculous. You cannot build it. And then building hardware is hard. So there's a lot of embedded systems designers here, people who have built products from the ground up. even the most capable engineer with their hands on a processor and a crypto stack and a wireless module is going to have a hard time building something from ground. So we're 4.5 years into this. We think that this is the wrong way to do things. We are partially to blame for it. And so we're going to try and fix this. So we're introducing this glorious thing called the DMN, the Decentralized Machine Network. And one point I want to make before I move on is that I'll talk about the technology pieces, but ultimately, for Helium to succeed, we have to be valuable to end users and customers. And so a lot of this stuff is technology because it's a technology-focused crowd, and this is the fun stuff. But we've got plenty of users now that we're transitioning over to this new stuff. And for us, we succeed when we are ultimately useful for enterprises and developers. So the development experience that people get on the forthcoming product, the DMN, is going to be very similar, but we're changing a lot of the underpinning infrastructure, which makes it possible. So what is a DMN? We have a blockchain. We got to have a blockchain. Who here has read enough about blockchain or used blockchain in some capacity to feel like they're generally knowledgeable on it? Wow, that's awesome. Okay, so fair amount of that. So for us, we're going after this original mission of building a public wireless network that is ultimately useful for enterprises and consumers. And the basic business prop is that as an end user, call yourself, these are not customer examples, but I'll call them examples. Walmart, for example. You get to deploy a device on a network tailor-made for the device data that you want to send that costs an order of magnitude less than anything that a cellular provider could give you, with a development toolkit that is an order of magnitude easier than anything you use on top of a cellular line. That's the general pitch. And so we haven't provided this to our customers. And so this is the way that we think we can pull this out. So I'm going to talk about all these pieces, but I'll just rip here really quickly. So there's a physical blockchain. So Bitcoin has popularized the Bitcoin blockchain. Ethereum has Ether's got the Ethereum blockchain. Monero's got their own blockchain. There's tens of different blockchains. We, about 6 months ago, went back to the drawing board and said, how do we deliver on this original vision to build a decentralized wireless network for our customers? And I'll be honest with you, it was a joke initially. Somebody internally said, we should just use a blockchain. We laughed about it for a month. And then a guy named Andrew, who goes by Bones, said, well, I'm going to think about this a little bit more. And he wrote a white paper, draft, 9-10 pages. And we all read it and we said, oh, that's kind of interesting. And so 2.5 months later, we had what we thought was a design for a very ambitious but ultimately useful implementation of a blockchain that was optimized for the physical world. So not a Bitcoin-style blockchain in that you're forcing computers to expend a bunch of energy and solve a problem, and then off you go. This is a blockchain that produces something real out of its proof of work, and for us, that real thing, that useful thing, is wireless coverage for devices and sensors. I'm not going to go deep into this stuff. I'm happy to talk about it after the talk or send people to other things, but that's the general thing. So we start with the physical world blockchain. Second is obviously a wireless network. So we're talking about the ability to connect devices, the next 50 billion devices that Gartner here? That Gartner, thank you, has predicted will be coming online by 2020, 25. And so we don't think the answer is cellular. We don't think the answer is any of the LPWAN players, the Sigfoxes, the LoRa's, the engineers. We think it requires something much, much more focused. And so we've built another wireless protocol, which I'll talk about in a second. Talk about why we didn't want to build another wireless protocol. And then lastly, we think that in order for this to succeed, and this kind of goes with the kind of the ethos of the blockchain, this has to be a very decentralized and ultimately open source effort. I can't convince an enterprise to build on us if they're not convinced that the components they're building on have longevity and can be around for the long term. So I want to be able to give this stuff away essentially under permissive licensing and say, go out and build your own if you want to do so. And we're building ecosystems around all of them. So this is probably the easiest way to visualize what the Helium distributed machine network is. And so just kind of walk through these components. So on the left, in our parlance, this is a machine. Hans was calling it a toaster. It could be, an agricultural sensor. It could be a factory floor machine, a printing machine. Anything on the edge that's sending and receiving data that has to make it back to the internet and is used in some sort of application. That's how we just did it. Generally, for us, the target machines are things that are running on smaller MCUs, so M0, M3, M4 class processors. They're supposed to be in the field for 3 to 5 years on a small battery, something 2 AA's or less. constrained memory footprint, not doing a ton of processing. That's what we define a machine. And this is it's kind of smaller. That's the Helium module there. So the Helium module is the embodiment of our wireless and security unit, essentially, which gets dropped onto a machine and then gets you on the network. So that's the edge. In the middle, and the crux of this whole thing, both in terms of the wireless and the blockchain capabilities, is this thing called gateway. So people are familiar with gateways, wireless gateways. So for us, the gateway serves two purposes. So one is that it's a very, very badass wireless gateway, essentially. So it is the way that we create the local low power wide area helium network. So imagine with me, if you will, a very soon near-term future where across the United States, thousands of these gateways are deployed, and they're building together the Helium decentralized machine network. That's what we're driving towards. And so any device that's running a Helium module or something that's compliant with the Helium wireless protocol, which we call WIP, which I'll talk about, can connect to any gateway that's in range. And then, in addition to creating wireless network coverage and routing data, I should note that gateways take data in on the front end with the Helium wireless protocol and route data back over either cellular, Ethernet, or Wi-Fi. So they're very, very dumb, unprivileged, untrusted devices from a security standpoint, which literally just take RF data and then fire it back over TCP/IP and vice versa. That's all they're there for. We don't do any processing on them. In the future, we might. They don't, talk to each other in terms of application. They talk to each other for purposes of our blockchain, but they're just literally very dumb devices that take sensor data, push it to the internet. They also perform the task for the blockchain. So they act as a miner as well. So generally in blockchain world, you've got a piece of hardware that is doing some sort of mining. For us, this is a gateway, and I can count them. And then lastly, we've got this piece called a router. So a router is an internet-hosted open source application that takes data from gateways and pushes it to ultimately what is your end application, vice versa. So Helium runs routers. We have open source routers that people can run. And this is kind of the brains of the operation on the routing side. And it does things like maintains a full copy of the blockchain, whereas the gateway only has to have a recent copy, or a very kind of truncated version, enough to know what has to happen on the network, but doesn't have to hold the entire blockchain. So I'm going to talk about some of this stuff more in depth, but generally, are there questions on this DMN architecture? Yeah.
How do you scale the deployment of gateways?
Yeah, so the question is how do you scale the deployment of gateways? Meaning how do
you make sure that they are available like all over the US or geographic?
Yeah. So I'll get to that in a second. Question back there.
Is the gateway your physical device or need to just run a software on the device?
Yeah, the question is the gateway our physical device? So for the moment it is. So it's something that Helium creates. It will soon be open source in every way possible. So the specification, the firmware, the hardware, the designs, and anyone can make their own. We're building out an ecosystem of manufacturers to do the same thing.
Suppose I have my own personal router.
Yep.
Can I add a sub patch on top of it?
Not just yet. So it runs some fairly fancy things. So the crux of the gateway is built around a software-defined radio, an SDR, and it lets us do very, very useful frequency hopping between stuff in the sub-gigahertz band. So we're using an SDR from a company called Lime, and it's tuned up quite nicely. So as of right now, you can't just drop something onto a something with a decent processor. So you can build your own if you want to. Yeah.
That question, so what's the benefit of adding your blockchain?
Yeah, so let's pause on that for 1 second. I'm going to wrap back around to that again. And it ties into this guy's question about how do we build the network. Okay. Okay, so a physical blockchain. So we set out to come up with a mechanism to help us build a distributed wireless network. And so I mentioned that we were founded in 2013, raised a bunch of money. From our seed round to our A round, we built what is, like the first version of the gateway that's in this development kit, which did very nice kind of long range, low power, secure wireless. But the range that we got, for example, in San Francisco for one of these was maybe a city block. So kind of interesting, better than your standard Zigbee gateway, certainly much better than Wi-Fi. But if we are to build nationwide coverage on that, it's going to be very hard. So we actually did the math. We talked to a bunch of providers like Crown Castle and American Tower who will sell you space to put cellular towers and other things that you want to run. Quite a funny conversation with them because they're used to AT&T asking for tons of big roof space and paying tens of thousands of dollars. They really know how to work with a small little gateway. Sigfox is trying to do this right now. They've built out a bunch of coverage across the United States and across a bunch of different parts of the world and have succeeded in some part. But it's ultimately super capital intensive. So we wanted a way to incentivize people to build coverage on our behalf, essentially. So this is a question that we asked. And so we said, interesting. So how is it that we can convince somebody who doesn't want to deploy a connected temperature sensor or connected toaster to build a network on our behalf? So we said, oh, interesting. What if we incentivize them to do it with a token, right? So without getting too into the weeds on what the Helium token is and the idea behind the utility token, essentially what happens is when you deploy a Helium gateway, you're creating wireless coverage. And in exchange for you doing that, we're rewarding you with this token. So as your gateway does work, you're mining Helium tokens on some set schedule. We've got a white paper that explains all this very nicely. But the problem is it's easy to spoof this, right? You could take the open source software, you could drop it onto an Amazon T1 Micro or something. You could feed our system a GPS lat long, which is part of the initiation process for getting this on the network. And you can start mining, we can just start pumping these tokens. But we needed a way for us as a network, and the network as a whole, to verify that people running gateways, so it could be me, it could be my mother, it could be Hans, it could be my brother, anybody, that their gateway was actually where they said it was, actually providing the wireless coverage. So, elaborating over a lot of details, we've built a proof of work function specifically tailored to physical world objects that we're calling proof of coverage. And so basically, gateways work as verifiers of other gateways to constantly challenge them and verify that what they're doing is creating network coverage for devices and sensors that are sending data across the platform. So to your question before, how do we build this out quickly? Essentially, we're rewarding people with tokens for building coverage. And so we're trying to solve the cold start problem with one of these sort of marketplaces by issuing a utility token as gateways do their work to basically see them. That's the short answer. And so somebody over here asked about the utility of the blockchain. So one is it helps us incentivize people to build it, but it also gives us some fantastic features, which I'll wrap back around. And ultimately, I think what you'll see from Helium is less talk about the blockchain and more talk about the features that it enables. So I think it's a really good thing. And hopefully what you'll see about us is that we're not just kind of jumping on this blockchain bandwagon because it's an easy thing to do. We actually have purposely, and this is just kind of a visualization of proof of coverage, we've purposely tried to not emphasize the glitziness of it, but the usefulness of the underlying technology, because we really do believe it. And so, proof of coverage. Okay, so that was a lot in about 5 minutes. Let's talk more about that after people have questions. I can direct you to white papers and videos. So we've got a blockchain running on top of a gateway, this mining rig essentially, which is very easy to deploy, requires very little power, probably about the same amount as an LED. And we don't anticipate that amount of power changing, for example, which is quite easy. So on top of that, we've got a new wireless protocol that we think is ideal to form this kind of machine economy backbone. And so it'll be open source quite soon. It'll be open in kind of every sense of the word. So it'll be open specification. All relevant source code is going to be open source. And you'll be able to implement your own devices that are Helium WIP compatible, or you can get device modules from ourselves or one of our manufacturers. But any machine running the Helium wireless protocol will automatically connect to the network. Some features of this are massive range, right? So in a city like San Francisco, we can deploy one of these new gateways and get about 1.5 miles radius from the deployment. And that's at the edge having a reasonably good bit rate. way out on the edge of where the gateways are deployed. Excuse me, you're probably looking at about 0.3, 0.4 kbits a second, which is not tiny. And then, it scales all the way up to about 40 kbits a second if you're right next to a gateway. But the thing is that because they're very, very inexpensive, so we'll soon be selling these probably June or July for about $495 US, which is pretty affordable. And the price is going to come down. Those are the first ones. So if you need more capability, you just deploy more gateways. So if you've got a farm deployment and there doesn't happen to be a network that exists there yet, you can deploy in a gateway and pretty much cover the entire farm. Now there's some caveats there. If you're going to put 50,000 sensors online and they're all sending a ton of data in parallel, you're going to have to fire up a few more gateways. But compared to anything else on the market giving these same properties, it's a lot cheaper. So extraordinary range, a ton of capacity. So I mentioned before that we're using a software-defined radio instead of gateway. I would invite you to read some more stuff on the gateway as we release it, and I'll send the slides around so you can and Paul and you guys can share this stuff. But we do some really, really interesting stuff with using this SDR to basically ingest all data across the whole sub-gigahertz spectrum in parallel.
Using what spectrum are you using? White space?
So it's all ISM sub-gigahertz. And it's all based on open modulation techniques like GSK and FSK.
Spectrum, like what? Frequencies.
Oh, so 902, 39. Right, so you're asking? Yeah, I mean, generally all sub-gigahertz. So not specifically between 902. Our current stuff is roughly 902 to 927 when sub-gigahertz is available. But we're with this new software-defined radio, we can listen to a much wider chunk of the ISM. So we're targeting applications that are reliable or rather, the protocol is reliable and has fantastic low power properties, meaning if you're building something that sends data fairly frequently, 5, 10, 20 times a day, I feel comfortable telling you that this thing will last in the field for 3 to 5 years, which is a pretty huge deal. And then open standards. So things like FSK, GSK, GFSK, all these open modulation schemes that are very well known and documented and run on commodity chips from companies like TI and Scilabs. We're trying to get away from the world where people are buying modules that are built on silicon that people have to try to reverse engineer to kind of figure out how it works. And so the idea here is that if you don't want to use one of Helium's or something from our manufacturers, you can build your own quite easily. Okay, and then this is roughly what the gateway will look like. It's quite lovely. I wanted to share that because we're very excited about it. Okay, and then I just wanted to visualize the end-to-end DNN rather one more time. So temperature sensor with a payload of 32 degrees Fahrenheit plus some of that long data. This is basically being generated by your end node in our where this is a machine. I didn't talk much about this, which I probably should have given that it's a security video. So the modules that we build and the spec that we push, we are using on hardware-based encryption for all devices that are joining the network. So everything ships with, at this point, an ECC 508 from Atmel, which lets us do key generation, storage, and authentication for the Helium infrastructure. And so every device, no matter how big or small, is part of the PKI that is between the router and the device itself. So we take very, very good care of people's data. And the spec pushes that as far as we can. So all data that leaves this end node is encrypted end-to-end. We never look at it by design. That's part of one of the value props that we have. And we couldn't really get very far with customers' conversations if we told them that their data was flying across this big, crazy distributed machine network and people who own these gateways were going to have access to it. Wouldn't work for us. So one of the reasons we can do this is because the gateway, and this is another rendering of gateway, the gateway is unprivileged or it's untrusted, right? The gateway doesn't actually look at it. It's literally just a dumb device that takes data in and pushes it out of the TC packet. So the gateway itself is responsible for the routing. We've got the blockchain, which imagine this kind of running as a process on top of this. We don't store any application data in the blockchain. We think that's the wrong way to do it. All the transactions obviously exist within blocks as they're mined, and we keep a fingerprint or a hash of the payload, so that if someone's storing this stuff on their own internal cloud, they have access to a set of routers which run an API to let you basically verify the validity of the data without looking at the contents of the data, which is. And then finally, all of this gets pushed to a data store of your choice or some sort of internal cloud. So that is the network data flow.
So the end nodes have their own ECC 508 in them, essentially?
Yeah, so every end node has their own encryption. And so what we do with these cloud providers, which is quite cool, which I'm going to talk about in a second, is we've actually done the work to integrate the end device and the key matter on the end device with the APIs for security on all the cloud providers. So so I wanted to wrap this up with a use case so people can kind of get a concrete feel for what this is ultimately going to be used for. In this case, this is a project that we're working on with a very large pharmaceutical manufacturer and a consulting company. And they came to us and said, listen, we've got hundreds of thousands of vials that store drugs that are super dumb. Like $3,000 to $5,000 worth of drugs in a single vial. It's produced at a manufacturing facility, dropped into a truck. It might be temperature controlled, but we just kind of bless it and say, good luck. Get to where you're supposed to go. And they have some insight into these things, but they generally don't have much. They know when it leaves. They know when it arrives. They cross their fingers. But they don't know if the temperature has fluctuated wildly. They can know generally what the truck is, but they don't have it down to the vial level. They don't really have good fine-grained location. They don't know things like, did it tip over, right? Did it spend 6 hours on its side? So they said, can you guys help us solve this problem? For them, obviously, it's quite valuable. A $5,000 vial is quite the thing. Can you help us track at the vial level the status and location of the vial? So we're in the process of building this, and it's quite a fascinating use case. So what we're doing is we're basically building a vial that's got a reusable cap. And in each one of those caps is a Helium module. And so in a module is the radio, which has its own processor, the crypto stack, and also an application processor, so an M3 sort of thing. And so these things get produced. The module itself gets produced fairly cheap, $3, $4, $5, probably $5 or $6 US at reasonable scale. Gets packed into this vial here, and then the network is being built out to facilitate this use case and other use cases. And this specific client is okay to deploy some of their own gateways to build network capabilities they need to as well, because that use case is that valuable to them. And then ultimately the data gets piped to their cloud-based applications. The one thing that I've not really talked about too much, which is too bad because I'm underselling it, is the idea that from the network and from this this proof of coverage, we build up the ability to do cryptographically provable location of a device. So generally, in an area where there's enough saturation with gateways and network density, we can prove the location of a gateway, and from there basically extend proof of location to a physical device transmitting data on the network. So through a few different mechanisms, one of which is very, very fine-grained timestamps, which we can get from gateways that are all in one area. We can prove, and this gets stored in the blockchain, it can be verified or refuted, the location of the device. So we can, in this case, give this client the ability to find out where exactly their files are, or where they were on the panel. So it's super exciting. So just to kind of wrap this up, so from a trust perspective, right? So why is a F100 company that is in the pharmaceutical space considering using something like this for a use case which is immensely valuable? So one is that, as I mentioned before, there's hardware-based encryption on all the modules and essentially all the systems, right? So everything with a module has a full crypto stack on board, ACC 508. ML's got a new chip now, ACC 608. Has anybody seen that? No? The new thing that they mentioned. There's microchip, I think. And so this does key generation, storage, and authentication. Super easy. And then kind of related to that is the idea of end-to-end hardware integration with cloud providers. So if you've ever tried to deploy any number of devices at scale using an API that AWS IoT or Google Cloud IoT or Azure IoT pushes as recommended, you're basically having to do per device keys by hand, which is a disaster. So we've automated that entire process end to end, and it's hugely valuable. We talked about this earlier as well, but gateways are privileged, right? So we're building this big decentralized wireless network, but the gateways really have no ability other than to route data that's fully encrypted. It generally makes an enterprise feel pretty good. Everything is open source. The specifications are open. It's all built on commodity components, so you can build your own module from things off the shelf, from Atmel, TI, Scilabs. And there will be an alliance that we're wrapping around this, so we're starting to talk about the decentralized machine network alliance. But it's easy to join. You can get all the specs for free. We're not asking people to donate a bunch of money and kind of be part of the time chain. So the link itself is fully bidirectional. So most of the time your devices are sending data, but sometimes you have to update something over the air. Or you have to do some sort of control. This typically won't have control. But last thing you want to do is deploy tens of thousands of devices, figure out there's some sort of leak in your code on your sensor somewhere, and then not be able to update it. So huge, that's bidirectional. That definitely ties in with security. No centralized infrastructure or ownership. The goal for Helium is that we bring this network to life with the help of people initially running gateways, and then it will just exist and live and kind of thrive. And success for us is a network that could exist if we were to step away. Clearly, we're not going to be stepping away, but we want this thing to build on itself and really be decentralized. And then lastly, I see as the feature that differentiates us the most from an application perspective, proof of location. The ability for you as a developer to put a Helium module inside of your device and do no additional work. You have to put any sort of GPS module on your own device. And get proof of location, very, very fine-grained location, at the most tens of meters, without doing anything additional, which is massive. So that's the quick summary. And so for us, the roadmap looks like this. We just announced this new stuff this month. So I was going to give kind of a deeper look at some of the security stuff, but this is, I think, maybe the third public talk out. So I'm just kind of excited to do a general look. So thank you for giving me your time. And we've got current generation hardware, which is this stuff here. And we've got a lot of people using it. We're transitioning all these people over to the new network. So the two lucky winners of this, hopefully you'll try it, like it, and then see kind of the future. So we will be starting to sell these gateways to people who will be the initial kind of network providers in Q3, which is coming up in a couple months. The blockchain itself is going to be built on or into a test net in August in San Francisco with a few of our early partners. And then Q4, this whole show gets started, right? So we light up gateways, the Genesis block is mined, and off we go. And then Q1, we dominate the rest of the world, obviously. That's it. So if you want to learn more, aside from coming to talk to me, we're helium.com. We're twitter.com/Twitter, or Twitter.com/Helium. We're Helium on GitHub. And so on GitHub right now, you can get the blockchain consensus protocol that we're using. Some really interesting stuff called the Honey Badger protocol that we're basing this stuff. We use a lot of Erlang internally at Helium. I'm not sure if anybody's fans of Erlang here. We've got a lot of great stuff that we're open sourcing. And everything I talked about either is open source or will be open source on some reasonable timeline, including the blockchain stuff. There's a white paper, which you should definitely read, whitepaper.helium.com. We're on Telegram. We just got that going. I think some decent good momentum in there. Not too many bots as of yet, which is encouraging. And then this is me. So Mark Phillips, Mark at Helium, and I'm local to Boston. So if anybody wants to sit down and grab a cup of coffee and tell me I'm full of crap. So thank you. This cluster here. So.
I have two questions, but I'll break them up with rounds.
Yeah.
First one, political barriers. How do you get past political barriers that prevent deployment of networks that bypass.
Hi, how do you get past political barriers that prevent deployment of networks that bypass the traditional carriers who make large contributions to local politicians? This is a real world problem that I was recently presented with.
Interesting. Yeah, so the question is, how do we get past local handshake politics that carriers are part of? I don't have a quick answer. I can tell you that if it gets to the point where carriers are coming after us, I'll be through. It'll be a good problem to have, because we'll be having some meaningful, effect on people's money. But I don't know. Okay. But I'm curious to know how you got into it specifically, because it's probably going to be relevant to how we're going about it.
I've learned that in New York City that there's been emergency network deployments that have been limited, that technically can cover the entire city, but politics say you have to go through the AT&Ts and
yeah, that's right. Yeah,
or actually Verizon specifically.
Talk more about that. Yeah, good question.
I have a quick question.
Yeah.
You said the blockchain is on the gateway, right? So in situations when this deployment is in a remote, for example, of the farm, for example.
Yep.
So is that an independent blockchain running on the network, on that subnetwork, or is it one public blockchain that's running on?
Yeah, it's a good question. So the question is, in a world where there's a gateway off on its own, is that gateway part of the larger blockchain? And the answer is yes, it should be. So they all form one kind of large network. There are some specifics around how we do. There have to be some geographic peers for us to be able to trust a gateway. So there are situations where someone stands up a gateway kind of in the middle of nowhere and it has no geographic peers. It's hard for us to trust it. So roughly the mechanism is built on a scoring system. So gateways are constantly verifying their usefulness in the network. So they're submitting these proofs of coverage, we call them, and they need to do some work based on some geographic peers for the proof of coverage to be valid. So there are situations where Helium will have to step in and deploy trusted gateways to the network, so they can be used as geographic peers. But generally, the current thinking is that we're not going to be breaking it up. There are some kind of, I think more on the wireless side, there might be some advantages to having kind of smaller networks. But as far as the gateway goes, the intention is for every gateway and the mining to be part of it. Oh, I'll disappear. Do you have a question?
Are you your own CA?
Are we our own CA? Yes. Yeah. Okay. For the key infrastructure?
Yeah.
Yeah.
How are you securing the keys on these devices?
So the device keys are secured by the ECC federal. So the routing infrastructure's got a mechanism for securing keys that we can get into after it's a larger discussion. It's a good question. One second. Okay.
Thank you. Quick question on, can you talk a little bit more about the overall economics of the proposition? The modules you had, I think, mentioned it was going to run about $3 to $5, but target price for the gateways, ongoing service costs, and things like that.
Yeah. So so we're targeting $5 US for the month. We think that's super compelling, and then it's got a radio plus a crypto stack and a processor for application. And as far as we can tell, talking to hundreds of customers, their applications are such that an M3 would get the job done. M4 would be fine. Maybe Hans has different ideas on it. On a not too far off timeline in the United States, most end users are not going to have to deploy gateways. There's going to be some, exceptions, right? So we've got a person building a proof of concept on a farm in McBee, South Carolina. And so they're doing irrigation monitoring and control. They'll probably be the first Helium deployment in McBee, South Carolina. So they'll deploy their own gateway or their own set of gateways to do coverage. But on some timeline, I'm hoping to be able to promise an enterprise that they're not going to have to worry about infrastructure. So as an end user, that's a very nice thing. So the mechanisms of the network are such that gateway providers essentially dictate the price for traffic. So as someone running a gateway, you say, I'm providing coverage in New York City. There's 50,000 devices in yours, so they might want to connect. I think the price of traffic should be 0.0005 helium tokens. Okay, so the way that you pay for traffic is, and we'll do some work to make sure that enterprises are comfortable with the idea that the price can fluctuate. Right? So if I'm modeling a device cost 5 years out, I need to know that traffic is never going to cost me more than 5 cents, 10 cents, 50 cents. So that's some of the work that we have to do on basically the product. But the thinking, we think we can get this pretty well nailed, is that as gateways are deployed and coverage is built out and saturated, the cost of traffic is just going to go down because you're incentivizing people who are operating gateways make money in 2 ways. You mine for tokens, but also you capture fees from people sending data across. So we think we can drive the connectivity costs pretty close to 0 on a long enough timeline. And then, does that answer your question?
Yes, it helps. I guess there's still a question on, is that brings up the other question of, still can't deliver SLAs, though, right?
Right, the SLA question. So we can deliver SLAs in the same way that Amazon can deliver SLAs on AWS. I mean, they promise 3 nines, you can pay for 5 nines, and if you don't hit 5 nines, they give you 2% of your bill back. So it's not going to be much.
I have a follow-up.
Yeah.
You know the low-bound carriers are rolling out 5G.
We don't think it's going to impact us very much. It's going to take them a couple of years, 2, 3, 4 years to get 5G to a meaningful place. And I don't know, maybe the gentleman from Rutgers got ideas on this. I don't know if it's how it goes.
This looks closer to NB-IoT.
Yeah, I think that's, so NB-IoT or LTE-M would be a kind of a closer comparison in terms of competition. The cheapest offering for NB-IoT from I think TCP right now is $6 a year per device. It's actually pretty reasonable. You got to buy about 50,000 of them, and the module cost is still off the chart. So, we're not too. What's that? Oh, yeah. So,
China's blocking up.
Quick question on that kind of a question. So
yeah.
You said that you're going to open source everything, and then what's the business model for Helium? Where actually you invest the money?
Yeah, that's a good question. So what's the business model here? So everything will be open source. We will have a business model that kind of revolves around 2 things. One is we will sell additions to the router, right? So the Helium router will be fully functional as an open source thing, probably less than the Apache or MIT. Or BSD. And then on top of that, if you want things like in-depth audit or reporting, or maybe we'll work with some providers to integrate some sort of analytics. That'll be part of the paid offering. And then we'll offer standard support for deployments, right? So if you're rolling out a 50,000 unit deployment, and you want Helium to, you want my phone number, that'll be part of the support.
You're not taking commissions from the blockchain transactions, right?
We're not taking commissions. No. These are so transaction fees are captured by the gateway operator. And so Helium, because we're kind of initiating the network, will be we'll hold some token, right? Some Helium tokens, but we're not emphasizing that as a thing that we think is key to the success of our company. We want the token to exist as a part of this ecosystem for people to deploy gateways and be competent, but we're not at the It's funny, we've been in conversations with investors who are interested in buying, another time.
Will I get rich by buying Helium tokens?
No, you will not.
That was actually the point line what I was going to ask. So you're talking about buying these gateways.
Yeah.
It doesn't make sense for them to have a complete rack of them because they're all going to be they're going to be sort of the same geographic area. So who do you see as buying the gateways that would make some money on?
Yeah, so I need to refrain from commenting on anything that's related to the value of the token because we don't know what that will be, and it's not a thing that we're really talking about for a variety of reasons. But it's a fascinating. So coming from a world where the Bitcoin blockchain's gotten the most attention, and you've got millions and millions of dollars dedicated to infrastructure to basically solve hashing functions. We're taking a completely different approach where we're trying to basically give anyone who's generally interested in the idea of providing network coverage, and maybe you don't have to be interested in crypto, but if you are, for a very, very small amount of money, $500 elastic at the gateway. You can be part of the network and actually do this online. And so it's actually a fun task to figure out how to make it hard for people to game the system. So I'll send you some stuff to read on this. But yeah, that's.
Okay, then totally different question. So this seems for 40K. It seems for low data requirements for IoT sensors. Small amount, you're not going to get video or you're not going to get video.
Right. Yep.
So it's really not going to be competing against too badly against the carrier.
No, I mean 40, quite frankly, 40K is on the high side of anything we ever see. I mean, when Hans showed the video, you know, the car application that you guys have using computer vision.
Right in the shadows. That's
yeah, I mean, closer to a use case that Hans showed would be something like the trash can, right? So maybe you have a trash can with a sonar sensor, and you can figure out how close it is. And that packet itself is very tiny. Yeah, so it's lower data rate stuff. 40K is on the higher side of what we see.
Okay, then this just seems to be for like supply chain or some things that you run emergency site. Doesn't seem to be geared towards the whole networks. Like for instance, anyone's going to have it. What happens if there's a disaster situation or space is saturated, power goes down, and then
right
liability.
Sure. Yeah. I mean, if the city of New York, somebody want to build something on this right now that would ensure people's safety, we go slow. You know, something that might be more useful would be some sort of distributed sensing application that was doing warning for kind of critical things, right? So we can get pretty fine grained with some accelerometers, and if you only get 10% or 10-second, 20-second notice of earthquake, that's actually super fun. That application might be more useful than something like emergency dispatch.
So, I mean, I think kind of expanding on your question, which is you use the example of the pharmaceutical company as a use case, and that's kind of a supply chain, kind of classic supply chain application. But in order for that to work, you actually would really need a pretty healthy web of these hubs or router devices across whatever geography that supply chain spans.
Yeah.
But it strikes me that initially, probably that's not what you're looking to do. Like, or maybe it is, but are you also looking to solve very localized problems? Let's say at the level of the individual farm or fishery, or in an urban system, smart city, smart town, and then by kind of solving those local problems at cost effectively, you then start to get network effects.
Yeah.
You can start to solve supply chain problems without needing a sugar daddy.
Yeah. So I guess the observation was that for us deploying a network, it's easier to solve problems where one can deploy a network and build the application versus expect the network to exist.
Right.
And by doing so, you'll expand the network in the same way. So generally, yes, is the answer to that.
And follow-on question: what are some of those use cases that you think are promising?
Yeah, that's a good one. So I mean, what I'll say is that our network, just kind of comment on how we're going to build up the network. So we get this question all the time, obviously. So we see the primary mechanism for network generation being people who. I'll just let that go.
It's okay. Aqueduct.
So generally, we see the most of our network coverage coming from people deploying gateways just to provide coverage. And additionally, it comes from two other sorts of deployments. So people who are deploying to get coverage for their application. So I mentioned that guy on the farm in McBee, South Carolina. That's a really good example. Right? So smart irrigation and connected farms is a super good example. We've got another company that is doing monitoring and analytics for data coming from HVAC. Machinery inside of like distribution warehouses and K-12 facilities is what they're focusing on. And so they'll be deploying their own gateways.
In that case, is the router or the hub kind of just plugged into their corporate network, or?
So one of the reasons why people like deploying Helium is because with a gateway that has a cellular backhaul, you can actually deploy this and none of the local network gets touched.
Okay.
So I can go on and on for hours about horror stories.
Yeah, sure.
Trying to get access to an Ethernet. Like turn on an Ethernet port inside of a hospital. cool, talk to you in 5 months. That's generally how it goes. So, and that's for good reason, right? You have to, that's a very scary thing. Yeah, so in that sort of deployment, you know, find some power, you put this thing on a roof or on a ceiling, and then off you go. So that's why they do it like that.
I was thinking another angle on the gaming of the system. Can I control which gateway I use? I mean, if I'm going to be paying a transaction fee to go through someone's gateway, can I control that? And, you know, conversely, can I cause problems in this market now because, well, I'm going to put up my own gateway over here, and I'm going to have a different kind of pricing structure, and then can I control my route through this whole crap?
So you are
so that it doesn't. I don't have microdynamics happening, negotiations for the fees just to get my data through this.
Yeah, so we built in some mechanisms around miners censoring transactions. So the idea that so in Bitcoin we see a lot of miners only wanting to process transactions that have a reasonable size transaction fee. I'll refer you to our white paper, but there's a pretty interesting piece of research called threshold way of punching on that way to the threshold.
Threshold cryptography.
There you go, threshold cryptography. Where so the way that we have the blockchain elects a group of miners that have a really good score, and then that group, called 30, is responsible for basically processing transactions. But the way that they do that is together using what was your name? Elon. So threshold cryptography. Where they essentially share pieces of a key, and then they can only decrypt this stuff when the key comes back together. So they have to work together. And so what that solves for us is so they can't look at a transaction. They don't know how much the fee is. So they just have to do it. So that's one way to get around it. But if you want to run your own gateways, you can do that. In fact, running your own gateways is a really good way to get cheap data because you're mining tokens while you do it, and therefore you can use that token reward to pay for traffic. But if you set up a gateway and they're charging exorbitant fees, then there's actually devices in that area that want to actually send data through. This is going to show up in the gateway. Cut your price down about that.
Well, that's what I was talking about. Is I would be the one coming in with a lower cost gateway.
That's great. I love
that. That might impact someone's business. For
I
example.
think that's what they are basing their ultimately cost.
Yeah, right.
It's not that it will be as equal to the
And you know we're not trying to say that people running gateways are what's that?
Evil geniuses.
No, I mean it'll be the proposition of running a gateway for mining rewards will be an obvious proposition. Is all I guess.
Don't you possess you kind of challenge once your input starts to build up? Like, let's say, take any node in, like, for an example, let's say nuclear facility where you kept a node there, and then when radiation levels increase, you need the coolant to jump in. So once your network starts to build up at that critical situation, it takes so many blocks. Like, for example, right now, you want to buy a Bitcoin, it takes 30 to 40 blocks to get verified, and then you know whether your transaction succeeded. So
yeah,
once your network starts to build up, you're going to face a new kind of a problem where some kind of critical applications cannot be even supported at your platform because
that's a good question. So what he's asking is, how do we guarantee that we can push transactions through the network as it gets crazy traffic, right? So there's kind of two mechanisms. One is for two systems that I think we've decoupled relatively well. One is the idea that the blockchain itself has to, assemble blocks and mine them. Right, so this consensus group has to come to a consensus across some network of what's in a block and call it a block and mine it. And so that'll happen fairly frequently. And so this protocol that we're using and the blockchain we built around it is pushing tens of thousands of transactions per second. But the more important thing in your question is, how does a nuclear facility looking for radiation levels actually feel comfortable about getting data back to their application quickly? So those two things are decoupled. So the transaction that goes into a block and is mined, put onto the blockchain and stored forever for people to look at, that does not keep data from reaching the cloud. That makes sense. So it's funny, I sent the record to one of our customers who was a long-time user, very, very capable. And for blockchain, first question is, if you got a ton of transactions and the blockchain is closed, how does, in this case, it's control data for a swing gate and gated communities. How do I make sure that this control data makes it through? And so the answer is that the two aren't really. So you can push data through the network, and then the transaction gets logged to the blockchain soon after, but not at that very long.
Follow up to that. Couldn't you have a situation where you have a gateway that comes untrustworthy, but it can't be refuted because the blockchain has been delayed by so much? So then you have a whole series of transactions that should be trusted, but then the gateway is being trusted for so long until the blockchain is cut off.
Right. So a situation where a gateway has become untrusted, but the blockchain still sees it as trusted.
Yes.
Yeah, that's a good question. I don't have a short answer to that. We'll have to do some tuning of the system. So trust is constantly re-verified. And even if a transaction is being pushed through the gateway, it has to go through a whole consensus group that's also looking at the transaction. So it's not just that one gateway that might end up being untrusted. But yeah, it's a good question. Does that answer it a little bit?
Kind of. Okay.
Yeah. Really, so I want to go on for people's time, Jeff. Let me do this drawing really quick so that people who have to go.
Okay.
If that makes sense.
Does everyone who wanted to put a card in the hat have a card in the hat?
All right, so I will.
Should we ask them what their project is?
Sure, yeah, so just, I guess, we didn't really talk. Anybody have a budget for this? So this is so what is in here is a Helium Gateway current generation stuff, which does our current generation wireless protocol. And there's a module, which is a development version of the Helium module, and then an adapter for an Arduino. So this drops right on top of an Arduino, M0, tiny, any Arduino module. You program this with an open source Arduino client, which is based on the Helium C client, all available on GitHub. And this ties into the Helium dashboard, which is responsible for taking that encrypted data, passing it to whatever cloud provider you want to use. All this stuff is obviously free. So we're not going to charge you anyone for ever using any of this stuff. The gateway is Ethernet back. So it's just a plug into a live Ethernet. And then you just, you can email me if you have questions. So, I mean, hopefully someone who's interested in hardware grabs this, but if you're not, even better, because you get to learn about it. Okay, I'm going to have unbiased Jeff here pick two of these.
And they can buy these on their own, right?
Yeah, so if, in addition to this,
These are on SparkFun, is it?
Yeah, so SparkFun and DigiKey and Monster are all distributors of ours. Actually running this competition right now with SparkFun and Hackster. Do we use Hackster? Yeah, so about 400,000 hardware developers. So
who mix those up well, Jeff?
It was a fully randomized sample.
Was it?
Yeah.
So running competition right now.
For next meeting, we'll get one of the spinning balls.
Yeah. So we're giving away a stupid amount of money and a trip to San Francisco for people building applications on Helium, SparkFun, Hackster, and Google Cloud IoT. Google Cloud IoT is giving away a bunch of free cloud stuff, and I'll send the link around this. And so you get this kind of hardware from Hackster and SparkFun as part of the competition. $10,000, I think, for first prize. Plus, wow. To San Francisco. Holy cow! Spend some time with us and the team. Second place. What's that?
So 10,000. Yeah, they'll get you a couple of lights in hot top.
Yeah. So 5K per second, 1,000 per third, and then it's just cool. Okay. So lucky winners. Vivian. All right.
Really?
Yeah. Trying to break. Okay, and then
This is going to bring the blockchain down.
Please. Oh yeah. So
then you're going to be our speaker.
All right.
Just this last week, I went through IoT hacking class.
You did? Yeah, so we would love to see you correct. And then Jay Wasserman. Hey, there we go. Okay, so everybody else should go to helium.com/store, and or there's a go to Hackster and free Helium, we'll call them at the top. But
Yeah, we got, we can wrap it up now. If there's
One more
questions.
question.
Yeah.
Actually. This will be the last question.
All right.
Because I'm a big guy. So as you're talking to pharmaceutical companies or agriculture, you're getting a sense of what their security concerns is and maybe a little bit of kind of what the threat model is for them. What are you hearing? Is it mostly just about data integrity and, making sure that we're not getting bad data or getting inaccurate data? Or do they have a particular adversary or threat model in mind that they are asking you about, or kind of lining up Helium's platform and saying, is this going to address this threat model?
Yeah, so we used to have a platform that was much more, so we tried, what's that? Pardon? No. So I feel quite good about the platform that we have now and the platform that we're moving to. We used to try and sell a cloud storage product. We had a fully built out API for storing data on top of the Helium cloud and retrieving data. We also had an environment that ran on the sensor that was a Lua-based sensor programming product. We moved away from that because trying to get, aside from the development hurdles, we could not convince any reasonable Fortune 100, Fortune 500 team that was responsible for data coming into an organization and coming out to just bring another cloud in and verify it plus. So we see mostly people concerned about the integrity of the encryption of data. So the questions we get asked are, so we work with companies who are designing their applications in such a way where even if you were able to decrypt a packet in flight, that you wouldn't even be able to tell who was using it. So for example, control of a steam valve inside of a facility, right? They don't want anybody to be able to know what some reading might actually mean in the context of it. But the majority of the things that we hear are around verifying and guaranteeing that data is never decrypted until it's, yeah, exactly. Cool.
Can we give a big hand for Mark? That was a great. We're honored to be the third talk.
Yeah, probably third.
All right. If you are interested in the June 19th event, come up. I got a card with the promo code on it. I will note also that as part of Blackworks, that company Senrio is, you mentioned the hacking the IoT. They're doing hardware exploitation via software exploitation, 1 day class and then 2 half-day classes that week of live work. So if you're interested, I'm not involved in it, but if you're interested, I can give you the link. And it's a good opportunity to learn from Margaret Carlton, who's come and spoken to us before from Senrio, and Stephen Ridley, their CTO. Thank you. Thanks everyone for coming out.
Thanks for having me. That's fun. Yeah, appreciate it. Thanks, Sean.
Yeah, that really cool.
Hi. Oh, Mark.
Sure, go right ahead. Systems that are taking technology.
Okay. Oh, there we are.
Nice. We're a fabric layer that goes on top.
Okay.
So we're a cloud-based platform.
Nice.
And we cover, just coming out of stealth mode.
Okay, cool. And you guys are here?
We're actually down here. For some meetings today, so.
I was actually down there last week. Okay.
No, we're
yeah. Okay.
We're alpha with our first couple of customers.
Great.
So are you guys working with?
So how do you put it all together?
Integrate. Sorry, so you guys
we actually integrate the applications that we what that endpoint is.
Over like the, that's great.
We have so much. I'm sorry. And then we pass that along. So we would set in the interim in your solution, but we don't hold data. You wouldn't see us.
Yeah.
The customer wouldn't see us. And we do not have any latency with the transaction.
Do you know that?
We have in our data center. So. So we solved that problem you were wondering about. Because the problem is that encryption and private keys and all that stuff, it's privacy, but it's not security. Right? Because the endpoints and the applications on the internet. So we protect. Basically, we provide security for endpoints without being on the big problem our customers are having is that it's a life expectancy of IoTs. They can't. There's no way to secure them over there. Like, because you can't touch them all the time.
Yeah.
It's
just not a practical
tools
thing,
and
so.
stuff. Yeah, he gave us.
Love your talk too.
That's great.
What?
Yeah, so that's.
Or used to work for IC. Yeah, I don't work there anymore.
A lot of the problems you talked about are the problems with coming out of stealth mode. So
Yes,
I'd
so-
love to give you a presentation. Let you know what we're doing.
Yeah, I'd love to.
We look at it as a lot of people are thinking about IoT security as devices. Yeah, we don't look at it all that way. It's completely wrong. We look at it from the first we start with concept. IoTs are primarily coded on applications and users. They're not standalone devices.
But I can
So
tell you,
have to
you know,
have
the
system
message we
security and devices
Sure.
and applications. And a secure container, right? So we create a virtual isolation container behind devices.
Yeah.
So
And then
some
some
of those
guys
some
came in
Thanks so
space
much.
and tried to
Thanks for coming.
use Manhattan and things like that, and then it's like the cable Wi-Fi